Welcome to part 2 of the command prompt. So if you have not seen part 1, you very likely want to go back and watch part 1 first, then rejoin at this point. So where we left off last time, we had covered all of the basic commands. We covered navigating directories, making files, just kind of being able to navigate our environment and manipulate some basic things like file management, creating files, deleting files, that sort of thing. So now we're going to look at something more programmer-like. We're going to look at some programming tools and how do you get programming done in this environment. And we're also going to look at some networking, some remote access tools to see how we can connect to other computers through this environment and work on those computers. So first, let's take a look back at where we are. We're going to do an ls-alf inside the demo directory. And we're going to see that I placed a bunch of files in here. And those of you who have any programming experience, you will notice those are programming files, or at least they certainly look like that. And they are, and at least the first few up there, main.c, main.php, .py, .rb, and .sh. Each one of those is a code file, and it's the classic hello world. So we're not going to really talk about programming itself. We're just going to talk about how do you use this environment as a programming environment, right? So just do a few more, a little more advanced things than we did in the first presentation on the command prompt. So let's take a look inside some of these files, something like what's inside main.php. So we'll do cat main.php. It's a standard hello world. Let's look at the other ones. You can look at main.c, standard hello world. Main.rb, standard hello world, this time in Ruby, okay? So you notice I have all of these different languages. They're all in the same place. They're all living happily together. Doesn't really matter. All of these are, of course, just plain text files. So one of the things that's important to remember for beginners, extensions don't matter, okay? Extensions are really there for the human so that we can tell the difference. Notice I have several files here all named main, but there's main.c, main.php, main.py, etc. And it doesn't really matter that much. The computer doesn't care about extensions. That's so we know what the files are. Now, in this case, each one of those extensions is indicative of the language I'm using for that particular Hello World program. And we can see very quickly, we'll be able to run these and we'll be able to do things. So, for example, if I want to run that main.py file, that's a Python file. Let's take a look at that. So, very simple. It's just a print hello world, okay? If I want to run that file, I need the Python interpreter, of course. So what I have to do is I have to send that file through the interpreter. Now, we're not going to talk about the difference between compiled languages and interpreters and all those kinds of things. We're not going to get into the details of being a programmer. The goal here is just to show you how you can use this environment to do programming and programming-like tasks. Okay, so the topic of actually programming, that would be a whole other topic. So if you're not into programming, if you have not done any yet, you don't have to really worry about it. You're just really trying to pay attention to manipulating this environment and seeing how things run. Now, if you do have some programming background, then this will make even more sense to you. But let's just take a look at that Python file. What does it say to do? It just says print hello world. Well, how do you get that thing to work? Okay, it's not a command. It's not, main.py. It's not something active that can do something, at least not in this form. So we have to have something that runs it. We have to have something that says execute this. In this case, since it's a Python file, that would be the Python interpreter. So the first question we have to ask is, well, is there a Python interpreter on this machine? Because if you don't have one, then you can't run Python files. So let's find out, right? One way you can find out very easily is by asking it. Okay, you can just say, is there a Python interpreter here? Now, since it's my machine, I happen to know there is, and I can just ask it by asking its version. Okay, I can say, hey, Python 3, if you exist, what's your version? And it comes back and it tells me it's Python 3.8.10. So I have Python here. I could have also asked the operating system. I could have said, which Python? I could have said, which Python 3? And the operating system will tell me if it's aware that there is a Python interpreter on this computer. And there is, and it's in user bin Python 3. You may be wondering why it says Python 3 instead of just Python, because there's also Python on here. Let's take a look at that. So which Python, actually I combined commands there inappropriately, but which Python, it should have just said which Python, not which Python version, which Python, right? And it tells me, yeah, there's also Python, notice without the 3. And if I ask that, Python, what version it is, it says 2.7.18. So I have two Pythons on here. Why do I have two Pythons? Well, because, again, this is a little off topic, but it might as well cover it. Python went through a major change between 2 and 3. Python 1 and 2 are compatible with each other. Python 3 is not compatible with 1 and 2. Python 3 is vastly different, and it's not backwards compatible. Because it's not backwards compatible, we kind of ended up in this situation where there's a lot of leftover Python 2 code out there, and a lot of it's tied to various operating system things. So we still have to have the regular Python interpreter, but you would never want to use it to produce code. So on my machine, I've differentiated them by naming one Python, the other one Python 3. That's all. But let's stick with the basics. I now know I have a Python interpreter called Python 3. And I can send it Python files to run. So what does the Python file say? It says print hello world. Well, what if I give it Python, the main.py file? It will run it. If I give Python 3 this file, it will execute it. Okay, and we'll see that very quickly. It prints hello world. Now, there was a difference between the code and the output. Right? When I look at the contents of the file is the command print hello world. The Python 3 interpreter reads that command and then does what it says. So since the command was print hello world, the output is hello world. Okay? So we just saw that we ran the Python file. So let's look at the rest of them. Let's clear the screen. And let's look, what else do I have there? All right? I've got a PHP file. Okay? So PHP, another language. Primarily a web language, but it doesn't have to be. PHP is a general purpose language. You don't have to run it on the web. You can use it for general programming. So let's take a look inside. And it shows us that we have PHP syntax. And in this case, the command for printing is called echo. Okay, so basically the same thing, same program, but just in a different language. So how would I run that? Well, same thing. PHP is an interpreted language, so I need a PHP interpreter. So again, let's check and see if I have one. I can say which PHP. It tells me that it's here. Okay, at least a version of it's here, but let's check the version. And it comes back and it says, okay, you've got version 7.4.3. Right? And we can run it the same way we did the other file. We can say PHP and it runs. Okay, exactly the same thing. I just print hello world. So I ran a PHP file. Very simple. We can do it with the rest of them too. I can do Ruby. I already know Ruby exists on here. So I can say run main.rb. Hello world. Again, if we look inside, let's see what's inside the Ruby file, just out of curiosity, right? It just says puts hello world. So in this case, instead of the word print or the word echo, we have the word puts. Same thing. It's a command, and when the interpreter gets its hands on it, that's what it does. So now we've just covered 3 different files. All of them are interpreted files. Now the next 2 are interesting. Another interpreted file, and then we have what's called a compiled file, a file that needs compilation. It's a compiled language. But let's go to the next interpreted language. Notice this one here, it says main.sh. Let's take a look at what's inside there. Right, so this is known as a shell script. This is the scripting language for this particular shell. Remember from part one I mentioned that a terminal environment, okay, the environment that you're looking at right now, shell environment, shell and terminal, more or less interchangeable words. It is a programming environment and a programming language itself. So the commands I'm executing and the things I'm doing here at the command prompt is also a programming language. And in this case, for shell scripting, it looks very much like PHP. It says echo, okay? So echo hello world. Well, this shell I'm in is called a bash shell, okay? And B-A-S-H, okay? Bash shell, right? So I can execute the scripting language for this shell by asking the shell to interpret it for me. So I can say bash main.sh, and I get hello world again. So the reason that this one is a little more interesting than the previous ones is even though it doesn't look any different and you probably can't distinguish, it has a little bit of an interesting quality to it in that I'm in the bash shell right now. Like what you're looking at is the bash shell. And then I can call the bash shell to interpret code in its own language, right? So you can write scripts in the language of the shell itself. It is a programming language. When you're working in a terminal environment or shell environment, you are in a programming language directly, okay? And you can use it that way. That has all sorts of powerful implications for how you can alter the behavior of what goes on inside your shell. You can not only program in other languages, but you can program directly in the shell itself, okay? So those are all what are known as interpreted languages. Notice in each case, I had to call the interpreter first and then give it a file. Right? I give it an argument. The argument is a file name with the file I want to run. And the interpreter will pick up that file and run it. Now, so all of those have a very similar mechanism, right? An interpreter, you give it a file, right, that has the appropriate language for that interpreter, and the interpreter executes what's in the file for you. The last example here is main.c. That's not an interpreted language. That is what is known as a compiled language. Completely different mechanism. Again, we don't want to get too deep into that because what we're interested in right now only is the command prompt environment, right? How can we use it? Okay, the programming is a completely different topic and far more complex. So in main.c, what we have is there is no interpreter. Okay, there's no way to take that main.c, give it to an interpreter, and have it run that file. Okay, it doesn't work that way. Compiled languages are different. You have to give that file to what's known as a compiler. Okay, that's different than an interpreter. An interpreter says, if you give me a file, I will read each line one at a time and just execute whatever it says. Okay, so it's just like following an instruction list. But in a compiled language, you give the file to a compiler, and the compiler reforms that into a binary executable. Okay? It creates another file, which then becomes executable. So it's a two-step process. In the interpreted case, it's a one-step process. You make the file, right, and there's one step. Give it to the interpreter and let it run it. But in a compiled language, you have to compile the file, that's step one. That will give you another file, and that file then runs directly. Okay, it runs directly native on the machine. Very different concepts. Let's do it. Let's see how it's done. So again, let's look inside the file just to see what's in there. Right, and what we see is a little more complicated. C and C++, if you've heard of these languages, they're far more complex than other languages, like say Ruby or Python, but still the same thing, right? The part that matters to us that we're looking at right now is the print hello world command, or in this case, printf. Printf hello world. Printf stands for print function, right? Now again, we have to compile it. So how do we do that? Well, I have to have a compiler, and let's make sure I do, okay? right? The compiler that I'm interested in for compiling this language is known as GCC. So I ask, hey, GCC, are you there? I probably have to give it 2 dashes here. There we go, right? And it comes back and says, yeah, okay, I am here, and this is who I am. It tells you the version, tells you what system it's running on, okay? Also notice, as long as I just made a mistake there, let's also notice what happens. If you make a mistake in a command, you'll get an error message. So the old joke in programming and the old joke in just computer technology in general is no news is good news. If you ever execute a command and you see nothing come back, that usually means it's okay, right? No news is good news. If you see an error message, we got to look at it and see what happened. What was the problem? And the error message will tell you what the problem is. In this case, it says unrecognized command line option dash version. Now, it's a very tricky error message because if you're not experienced, you would look at that and go like, what's wrong with that? I'm giving it the dash version. But as you see, what was wrong with that was it needed to be dash dash version. All right, so I do have a compiler. Let's compile this. GCC main.c. Now, remember what I said, no news is good news. So I execute the command and it looks like nothing happened. But what that means is it was successful, okay? Now, how do we know it was successful? What's the difference here? Notice in every other case, look what I did. I typed PHP main.php and I got the answer back. I typed Ruby main.rb and I got the answer back, okay? I typed bash main.sh and I got the answer back. But this time I typed gcc main.c and nothing came back. Question is why? And the answer is because it's a compiled language. And the first step is turn that text file into a binary file, or two-step process, okay? Let's take a look at our directory. Notice there's a new file there and it has a different look to it. There's a file there that says a.out, okay? That is my binary file that came out of the GCC process. That's the executable. And how do we know it's an executable? Well, look over here at the permissions. We see these permissions, these letters, RWX, in groups of 3, okay? And you look here, you see RWX, RWX, in this case, this last one, R nothing X. What those stand for is read, write, execute. And the reason there's 3 groups of 3 is we generally have 3 levels of permission. Okay? In a networked environment, you're going to have different levels of permission for different people. Okay? For example, you're going to have root, which is the highest level of permission. You're going to have the owner of the file, which is another level of permission. And you're going to have the world, right? Like anybody in the world can access it. That's another level of permission. So we're not going to get into that. Those are more details for networking environments and things like that. We want to stick to just talking about the command prompt. What we want to pay attention to here, though, is our a.out has X's at every level of permission. What that means is that file is an executable. It is a command now. You can execute it directly. So for example, when I type ls, right, that's a command. That's no different than what I just made. ls itself and most of the commands are nothing more than executables stored already on your computer someplace else. Somebody else wrote them in a programming language. In this case, more than likely, they wrote it in C or C++. They compiled it, just like you saw me compile, and they put it on the machine somewhere. And we can see that, like, where is ls? Okay, I can ask the computer, which ls do you use? And it tells me there's a directory called bin, another directory called ls, and in there is an ls command. Okay? And we could look at that by using ls itself. Right? We could go look in there and we could investigate, like, where is ls and what does it do? What does it look like? We're not going to do that. But just recognize that when you have a command, it's just a program that somebody else wrote. And more than likely, a compiled program, okay, which is what we just did. So just like I can type ls and make it do something, I just compiled a C program, and now that itself is a command. I can type a.out, right, and it'll run. It says hello world, okay? So notice that's a big difference between how the interpreter works. The interpreter is a executable itself. then you can send it a file to be interpreted. It will run it. Whereas in a compiled language, the compiler is an executable. You send it a file, it turns that file into another executable. That's the extra step. That new executable becomes a command itself, which then can be run standalone, like you see here. So once I compile something, it becomes divorced from the interpreter, or from the compiler, sorry. That's different than a compiled language. When you're using a compiled language like PHP or Python or Ruby or a shell scripting language, that file is tied to the interpreter. Right? You can't run it without the interpreter. The interpreter is necessary. In a compiled language, once you go through the compilation step, the resulting executable is divorced from the compiler. I no longer need the compiler to run that. It runs itself. Okay? And that's what we're looking at here. Now, why is it called a.out? Well, it's called a.out because that's the default name. On Mac and Linux, it's the default name. If you don't tell the compiler, make a different name, then it will just call it a.out. Okay? On Windows, it'll call it a.exe. Right? And you run it simply by giving the name. Now, a particular thing that you might run into when you try this process yourself is you'll compile it, you'll see a.out, and then it won't work. Right? You'll type a.out or a, whatever you want to type to get it to run, and it won't work because you need to say where the file is. So you need to say, for example, the current directory, like I just typed there. The dot, remember the dot is the current directory. We covered that in part 1. Slash separates directory path names, and then we go a.out. Okay, so we can do that, and it'll still run. It says hello world. But notice on my computer, it also works just to do a.out. So why is that? That's because I've configured my environment to eliminate that other step. That's not done by default. So if you ever compile something or you ever try to run something and it's in the current directory and it doesn't work, it's probably because you're missing the /. Okay, you're going to need a /. And remember, in Windows, the slash goes the other way. So in Mac and in Linux, the slash is a /. In Windows, it's a \. The point being, though, that normally you have to add the prefix the current directory, which is a /. But I have my environment set up, most programmers do, to eliminate that step. So as a programmer, or as a technologist of any kind, whatever you happen to be, you're going to want to configure your environment so that it's easy for you. I find it really annoying to have to consistently tell a.out, tell the compiler where a.out is or anything is, right? So I eliminate that by configuring this environment to include that, okay? And we're not going to worry about that right now either because that gets a little more complicated step. Right now, the important thing to notice is that we've created an executable. Now, could I have named it something else? Like, sure. In the compiling stage, let's go back to that. In the compiling stage, if I wanted to be called something else, I could have added a .o that stands for output. So I can add a switch. And then I can give that switch a parameter. I can say hello W. Okay? So now I'm telling the compiler, yes, I want you to compile this file, but produce hello W. Right? If I do that, no news is good news. Let's take a look and see what we got here. Okay, so we have a hello W. Okay, and it's the same thing. If I execute that, it's going to be the same program because I got it from the same source file. I just get a hello world. All right, so very easy stuff, very simple stuff. But now what you know how to do is you can configure your environment a little bit better. You can now run things. You can see how you can create program files. You can run it in this environment, and you can pretty much run anything. And you can run any language you want. All you have to do is install the necessary tools. You need, compilers for compiled languages. You need interpreters for interpreted languages, and you can run anything and you can do anything. So now that we know that, let's take a little bit closer look at what you can do with shell scripting. Okay, so let's take a command that is very useful, that people use very often. Technologists use this very often. When you want to see what processes are running on your computer, you do this. You type top, and you get something like this. Okay, so you can see lots of things are running on my computer. Okay, and it looks like I've got all these different processes running. There's a lot of information here because even though I'm not running a lot of different applications myself, the computer system itself is running a lot of applications. So what we're seeing here is all of those things. We're seeing all of the background processes, the operating system processes, and it gives us a lot of information on what's running. So you're going to need this, right? You need to know what's running on your machine and how many resources is it taking, how much CPU is it using, how much memory is it using. So we can look at mine and we can see, well, what's taking the most amount of CPU resources up. Looks like the program I'm using to record this. So Simple Screen Recorder. Okay, Simple Screen Recorder is taking up 1/3 of CPU time. Okay, and that's processes, right? And it's using 1.4% of the memory, not very much. And it's interesting, right? You can look at all these things. But what's not cool about this is it's showing you a lot of stuff, and it's only showing you the first like one page, right? You don't see the rest. What if I wanted a better top? I want a top that's specific. I want it to just give me what I want to see, and I don't want it to give me everything. Okay? And what we're going to do is we're going to see how I can do that. I can make a shell script that will give me what I want to see from top and nothing else. And then what happens is it looks like it's a command. Okay, so let's get out of top here. I'm going to press Q to quit. And I know that there's a thing on my system called pulse audio, which is controlling my sound. Right? It's my sound system, right? Or it's the sound drivers. So what I want to do is, let's suppose I wanted to look up pulse audio. I want to see what it's doing alone without all this other stuff in the way. Okay? What I can do, I have another command called mytop, okay? And I'm going to give it the name of what I want to look up. And I'm going to ask mytop, what do you got going on? Okay? And what I see here is it shows me just pulse audio. So now I have a little more refined version of top that works the way I want it to work, as opposed to the generic top, which just gives me everything. The question is, how did I do that? And that's what we're going to learn here. You can do anything in this environment, and you can get very sophisticated with what you do. So now that I've shown you that I've created a new command that's not normally on the machine, and I've configured it to work the way I want it to work when I want to look up something specific with a top command. So let's look at where is that thing, okay? So I happen to know where it is, so we're just going to go there. I have a directory in my user directory called bin, so we're going to go there, cd user directory bin, and we're going to look in here and see what we see. And this is where I keep my personal programs, okay? So these are things that I made up to do what I want to have done, or some of them are not things that I made up. They're things that you know, other vendors made up, and I put them here because it's an easy place for me to get to them. But I have a directory in my home directory called bin where I keep my personal executables to do the things that I want, and a lot of them I made up, right? So the point now is you can create any commands you want. For example, this machine is also a web server, and it uses the Apache web server. And when I want to restart Apache, it's like 3 or 4 commands to get through that or to check it or whatever. And I don't want to do that. I like to just type one thing and get it done. So I have a command here called restart Apache that does what I want it to do simply. Okay. And I have, look at here, my top. That's something I wrote, put into here, and it allows me to execute top the way I want to execute it. So we can take a look at that. What is that thing? Well, you don't know by just looking at it, but I know because I made it. It's a shell script. It's like that main.sh thing we made, and it's very simple, and it executes top, but it executes top with some extra parameters that allow me to execute the way I want it to execute. So let's take a look at it. Since I know that it's a shell script, I know it's a text file, and I can look inside of it, right? And there it is. That's it. That's the whole thing. It's a very short program, but it is a program. And what it does is it says, execute the bash shell, then execute top with these switches and arguments, right? So we're not going to get into what those are, it doesn't make a difference. It basically comes down to this. It comes down to just look for the thing that I told you to look for, and then tell me about it. And then it checks to see if it didn't get anything, then it'll also just come back and say no processes with that name. So let's say I give it the name of a process that is not running. It will give me an error message back and say, nope, there's no process with that name. But if there is a process with that name running, it will show me the top information for just that process, right? And this is a programming language, and like it's small, but officially this is a program because it's using a full-featured program language. I got an if statement here, so it works just like a programming language does. So now, one thing, if you're paying attention, you should be curious about is, remember that this is a bash shell script, and when I did things with a bash shell script before, I had to use the bash interpreter, but I didn't this time. So if you were really paying close attention, you know, something changed. There's something that's inconsistent here. That before, let's go back to the demo directory. Right, whenever I ran these interpreted files, the main.php, py, rb, sh, right? When I wanted to run main.sh, what I had to do was I had to actually call bash first and then tell it to run the Hello World program. But my top, which is just another shell script, okay, that I wrote, I did not have to say bash main.sh to run it. It just ran by itself. So if you were watching carefully, that should be a question you have, which is, well, how come when I ran this script, I needed the interpreter, but I ran the other script, I didn't need the interpreter? The trick is, I did need the interpreter, I just hid it. Okay, I just hid it, and I gave myself a little bit of a slicker way of doing things. Notice that in the my top script, notice this first line, right? That first line says start the interpreter first thing. So what I did is I moved the call to the interpreter from outside the program to inside the program. And I'll show you that. I can modify main.sh here and do the exact same thing. So let's do that. Let's open up main.sh, right? And let's put that line in. All right, so I'm gonna put that line in, and now I'm gonna save it and quit. So I've altered main.sh a little bit. Let's verify that we did it. Notice that everything I do, I always verify, and you should too. Never do anything without double checking yourself. So I've altered that file. Okay, main.sh now has that line in the front of it. What that does is it allows the interpreter to execute as a command of the file itself. But I'm not quite done. It's not that simple. There's one more step. I also have to make main.sh executable, and it's not. Okay, so right now it says read, write, read, write, read. I have to make it executable. The command to do that is called chmod, right? And then I give it the appropriate parameters, right? Now, no news is good news. And we take a look. Let's look at the difference at that file now. Notice the file up here. It just got read, write. Now notice it's got read, write, execute. Okay, that makes that file executable. Also, the very first line of the file says, start the interpreter to interpret this file. Now that I've made those two changes, main.sh becomes what looks like a command. It's not really, right? You're kind of playing a little bit of a trick. It's not really a binary. It's not like a.out. Okay, it's not a binary file that runs native on the machine. It's still using the interpreter, but now I have the option to do this. Just type main.sh, and it runs by it's seemingly running by itself. That's not true. It actually called the interpreter, okay, and just like it did anyways. But I've hidden that little detail, and now I can play another trick. I can take it one step further. Let's rename main.sh. Let's rename it to, we'll call it HW, okay? So let me give it a little more descriptive name, HWorld, okay? Let's rename it. Let's take a look and make sure that was done. Okay, it was. I now have this hworld file. Now let's call hworld. And it says hello world still. That's the trick of it. I didn't actually make a true binary executable. I didn't actually make a true command. It's still a script. It's still using the interpreter, but I've altered the way it looks and feels to the point where it looks like a native command. It looks like using ls or cat or any of those commands. And now I have a new command, right? And that's all my top was. My top was nothing more than I took a few command line lines that I could have typed out if I wanted that behavior. I put them in a file. I then put at the top of the file, execute this interpreter first. I then changed the execution permissions on the file to make it executable. And I give it a name that makes it look like a cool command called my top. But really all it is, it's just a series of things I could have typed at the command line. I'm just too lazy to do it. I'd rather type my top. So now you see two different ways that you can make your own commands. You can program them in C or C++, you can compile them, and that makes native executables. Native means it's executing in the binary language of that machine. Okay, in this case, my machine, right, a Linux machine. Or you can make shell scripts, or you can make anything. Okay, we'll do it with a Python file. We just did it with a shell script. Let's do it with a Python file. First, let's ask the computer which Python 3. It's going to tell us it's user bin Python 3. And let's open that file up and put the interpreter inside the file. All right, and we want to get the, you're going to need the first command here. All right, and we're going to save and quit. And now I'm going to go through the same process. I'm going to say, okay, take that main.py file. Let's change the permissions on it. All right, and now let's take a look at it, make sure it's executable. Okay, it is, it says main.py. And let's give it a new name to make it look a little slicker. Let's hide the fact that it's just a plain old Python file. Let's give it a name. Instead of main.py, let's change it to hello WD, I guess. I'm trying to give it different names so I don't conflict with each other. Okay, so we'll just call it hello WD. Okay, we'll change that. We'll double check that. Okay, and we have this. Now we have what looks like a new command, hello WD, and let's execute that command. And it runs, hello world. So now I've made 3 different things with 3 different languages in 2 different fashions, one compiled, one interpreted. All of them behave as if I've just programmed a new command. And you can program, so you can program anything. You can do this with Python files, Ruby files, anything you want. You have every programming language available to you. You have every environment available to you. You have every method you need to get to any part of the machine, all because, right, you're working in a command prompt environment and you know what you're doing. Right? And you can do all sorts of things that really expand the power you have over the computer, right? Now, that kind of ends the programming we want to talk about. We're going to talk about one more topic in this environment, which personally I find to be the coolest topic in this environment. And we want to see, let's connect to other places, right? Let's see what else we can get to and what else we can do, okay? So what we're going to do is we're going to take a look at, I have a website, and for some of my work at Texas State, so let's do that. Let's take it at Texas State. All right, so here's my website at Texas State. It's where I went to school. It's where I got my PhD. So I have a website here that has information about me and my research and all that kind of stuff. That's not important. What's important is that we're looking at something out in the world. It's on a web server somewhere, right? It's not here physically in front of me. It's somewhere else. Okay, and that's all that matters. It's just somewhere else. Okay, so let's take a look at that somewhere else and see if we can get to it and see if we can figure out what's going on. So let me clear this out, right? And what you need to know, which I know just because it's my website and I know this stuff, you need to know what the computer is that is hosting that website. So I happen to know that this address up here is on a computer inside the Texas State network, okay? And I happen to know the computer's name is Zeus. So what I'm going to do is I'm going to connect to it, right? I'm going to connect to it and talk to it, and then I'm going to go see my website from inside the web server. So I can do that with the SSH command. SSH stands for Secure Shell. Now think about what the word there, right? That word comes up again, shell. What I want to do is I want to create a shell environment someplace else, okay? And that someplace else in this case is going to be inside the Texas State network. So I'm going to come over here and say execute that. It's going to say you want to continue. Yes, I do. All right. I'm now talking there, but I've got to give it the password. So let me do that really quick here. And I'm in, okay? Now, this is where it should be interesting. Look at my prompt. It's changed. Remember, way back in part 1, I explained you really kind of need to know the name and your name and the name of the computer, because that will change as you connect to other machines and you talk to them, and you can dig deeper and deeper into networks, and your name and the machine will keep changing. It's very easy to get lost. Okay, so that's why the prompt has that information right there. So now what this is telling me is I am now a new user. I am AMK181 at Zeus, right? That's a completely different computer, completely different person. Well, I mean, it's me, but it's a different account. Now, everything I execute and everything I do in this environment, it's not on this machine anymore. I'm over there. So I physically, of course, didn't move. And if I want to change my website or do something different, I'm not going to drive all the way to Texas State. I live more than an hour away from Texas State. I'm going to drive down there to fix a typo on my web page. Right? I can connect to that machine. I can talk to it, and I can do whatever I want. Okay, whatever I want from my permission level. So let's do this. Let's clear the screen, and let's take a look. What's going on in here? Okay, so looks like there's only one folder here. In my account on Zeus, there's only one folder, and that folder is public HTML. So I have my first clue. That's my website, right? So let's go inside there, and let's take a look inside there. There's my website. So what you're looking at here, this website, okay, it has to be a collection of files somewhere, right? Somebody programmed it, in this case me, and they put it someplace, in this case Zeus. And it has to be a web server, and it is. And then if you go there with the right address, you get a web page. And that's what you're seeing here in this list. This is the actual web page. Now, this is very simple. I'm not going to say it's programmed well, because it's just a simple page, just sits there and doesn't do anything. But this is the page, right? This is the web page itself, the index.html file. So let's take a look at it, and let's see how we can make things different. So right now this says my name, and it says PhD after it. Let's suppose I was like, you know what, I don't want it to say PhD. Let's put like the title doctor in front and get rid of the PhD on the end. I want to change that, okay? I actually don't want to change that. That's not an appropriate way to list my name, or any PhD's name. But let's just say for some reason I wanted to do that. So let's take a look. Let's go back over here. I can open up that file. And I can find the place where my name is. Looks like, let's see, where's that? Down here somewhere. There it is. Okay, so here's the line where my name is. And I would like it to read doctor instead. Like that. Okay, and we'll get rid of the PhD since you can't have both written there. I mean, you could, but it's a little weird. Okay, so I want it to say that now. I don't actually want it to say that. I'm just demonstrating. So I'll write and quit. Now let's come out here and refresh the page. There you go. Change my website. Okay. The point being, I need the command prompt. Okay. I need access. I need to get to that computer somehow. I need to be able to talk to it. And now there are other ways to do it. So if anybody's familiar with web programming and you've actually deployed a website, of course you can do this with graphical FTP programs and graphical IDEs that connect to websites. And of course in the professional world you would. Okay, so that's true. But you need to know that you have this other way available to you because it's going to come up. There are going to be times you have to do it this way, that other access isn't allowed, or you're going to be doing server administration or database administration or something like that where you need to connect. So now my example, a good web programmer who's actually working on professional web applications, they have a whole host of tools, and they're not going to just go out to the command prompt just like I did right now to make simple changes. They're going to have very fancy, very big tools to do these kinds of things. But you also need to be aware that you can do it simply, and it should be cool, right? Like I just literally went to another computer, and I have control over doing things on that computer for my permission level. Also, you should notice a little bit different thing over here. Notice that the owner is AMK181, my group is student. So this brings up the idea of the multi-user environment where you see now some differences, and you see where permissions are different for different levels and things like that. You got group, you got owner, you got the world, and different levels of permissions for different people. So let's do this. I want to go back and I want to fix that again. I want to put it back the way it was. I don't want to say doctor. Let's put it back the way it was. And I will write and quit. Now let's go back out here and verify that we've actually changed it back. And I have, okay? So now you can see the power of the command prompts for getting to other places, other resources, and then you can use those things. So let's go deeper. Okay, now there's more we can do and there's more we can see. As an example, I know that there's a compiler laboratory, a research laboratory inside the computer science department. And I know it has some cool computers, and they do compiler research there, and they do high performance computing research there. I know the name of that computer. I also know that you can't normally get to it. If you try to get to that computer directly, you can't. But I can from here, because this thing, this machine, Zeus, it's exposed to the world because it's a web server. It has to be, right? If it's going to serve content out to anybody who asks for it, which is what a web server is supposed to do, then that must mean it's open to the world. And here's the trick. It's open to the world, but it's behind the firewall. Since it's open to the world and behind the firewall, if I connect to Zeus first, I can now connect to anything else behind the firewall, which is not open to the world, okay? So I know that there's a computer in the compiler research laboratory, and I know the name of the computer. The name of the computer is Nuth, okay? And I know that if I type SSH from here, I can hop over to Nuth. Now, keep in mind what I'm doing, right? I went from my computer to Zeus because Zeus is open to the world, but behind the firewall. And now that I'm in that position, I also happen to know the name of another computer that normally you can't get to unless you can get past the firewall, right? And I'm already past the firewall. So I'm inside. And now I can, from here, remember, Zeus is the one executing SSH this time. The first SSH, my computer executed. But now since Zeus is executing SSH, Nuth won't complain, right? Nuth just says, okay, hey, I know you. You're Zeus. You're supposed to be here. And welcome, and what's your password? So I'll do my password. And I'm in. Okay, so here I am on Nuth. I am inside another computer. But now notice that there's something wrong with my prompt. Okay, my prompt isn't giving me cool information anymore. On my computer, it said I was me on my computer. And then when I was on Zeus, it said I was me on Zeus. Okay, but here it doesn't say anything. And the reason it doesn't say anything is because this is a very basic shell that doesn't give you much information. And now we're going to bring up another thing you can do with the command prompt. Well, I don't like this shell. This particular shell is very basic, almost has no functionality that I like and that how I like to work. So what can I do about that? I'm on a different computer someplace else, and it doesn't give me the interface that I like. I can tell it to give me a different interface. I say, you know what? I don't like that interface. I like the bash shell interface. Give me that. Now I have the bash shell interface. okay? But I'm still on news, right? You should really start to be realizing the power that you have in this environment to control these machines, right? You can tell them to do whatever you want to do for your permission level, okay? So now that I've got the environment that I want, let's take a look around. Let's see what's here. Okay, let's clear it, and let me do an LL. And okay, so what's here? I'm in my home directory. So you notice I'm in my home directory because of the tilde here. And what do I have here? Looks like not much. I haven't been here in a really long time. You can see I haven't been here since January 20th, 2022, but I probably haven't actually worked in here since 2021. It looks like the last thing I have in here that I forgot to delete a long time ago was I had a homework assignment when I was still going to school there, and I must have left it behind. Okay, doesn't matter what it is, and we can go in there and we can look at it really quick. So I had a homework assignment. What was my homework back then? It looked like I was doing C stuff, right? So this was high performance computing, and this says MATVEC, and it's in C. So it looks like I was doing something that was doing matrix vector, probably calculations, and it was written in C. Okay, so all of this is probably just that. I don't remember what it was. But it doesn't matter. We're talking about the command prompt. We want to look around and see what we can see. So you can see I am now on another machine. I have full control over this machine from my permission level. I can check and see, well, what's on this machine. Is the G++ compiler here? Okay, and it is, right? I can look and see what all sorts of things are and how they are. I can back up a directory. I can look around again. This is my user directory, so let's back up one again and see what's above my user directory. If I look above my user directory, well, I can see there's a bunch of people here. These are all usernames, okay? So this is me, okay? That's my directory on this computer, and it looks like these are the other people who have access to this particular computer. They have user accounts. I don't know who any of them are except one person. I know this person right here. That was my professor for high performance computing. So that's my professor's account. I don't know what any of the other things are. But you can see I can look around, right? I can see what's going on here. Now I'm not going to poke into anybody's stuff, so I'm going to go back into my directory. Right? Let's stay here. Let's execute some other commands from here. Right? Well, now that I'm on a different machine, what can I find out about this machine? Well, I can find out anything I want about the machine. I can say ls CPU, and let's take a look like what's going on in this machine. What kind of machine is it? Right? So I can see it's a 86 architecture, 64-bit. It runs 32 and 64-bit. It's got an Intel processor. I can see it's a couple generations behind the machine that I'm on, a little bit slower. I can see how much memory it has. I can see how many core. Now this is a 12-core machine though, so it's got my machine is 2 generations forward in higher gigahertz, but 8-core. This is 12-core. So interesting for people interested in hardware, right? If you want to compare those machines and say my machine versus this machine and say, well, which one's faster? Which one's more appropriate for parallel processing? Which one can execute things faster? And in this case, the answer is it's going to be a toss-up because even though my computer is a little more modern, it's 2-generation processor forward and it's faster gigahertz, it has 4 less cores. So between those two things, it's going to be it depends on what kind of programming you're doing as to which one's going to be faster. Now, I happen to know because I've worked on this machine that in general, my computer is faster. But it's just interesting to go through these things and to look at these different qualities of the machine, especially if you're going to be a deep technologist and really be digging deep into these kinds of things. So we can look at that. We can look really deep, and we can see some really detailed information. It's not going to mean much to us right now, but I'm just going to make the point. We can do an ls hardware command, and now we got tons of stuff. We're not going to go through any of this, right? You're just going to see that this really digs deep and starts telling you a lot, okay, about what's going on inside the machine. And you could do this all day, poking around and figuring out what's what, and writing programs and like anything you want to do. The most important thing to take away from this thing is, though, look how far I've gone and the power I have, and I've never left the command prompt. I can do anything. I can write programs. I can compile programs. I can interpret programs. I can move from machine to machine. If I know what I'm doing and I know where the connections are, I can move anywhere and do anything, right, based on my permission levels, which is usually substantial. There's a lot of things you can do, right? There's a lot of things you shouldn't do, but there's many things that you can do, right? So this just shows you navigating through the command prompt environment how much control you have over these things, okay, over these machines. So now I have to get out of here, right? I want to get out of news. How do I get out of news? Well, I type exit, okay, and that backs me up. Where does it take me? You got to think, what path did you take to get here? That's the one that's going to take you out. So if I type exit once, I didn't leave news, because remember, while I was on news, I executed the bash shell. So the first exit kills the bash shell. I'm still on news, okay? If I do a uname, it tells me Linux, uname -n, it tells me I'm still on news, okay? So the first exit killed the bash shell. The second exit kills the connection to news. But remember where I was when I connected, I was on Zeus. So now I'm on Zeus again, okay? So I got to get out of here. So I type exit again, and now that connection's closed, and I'm back home, right? I'm back on my computer. Now, anything I execute now is going to be on my computer, okay? So that ends this part 2 of the command prompt. I hope this is giving you an idea of some of the things you can do. And the truth is, we've barely scratched the surface. This isn't even 1% of what you can do. But it's all the basics you need to start understanding what you can do. There's so much more you can do in this environment, and you should see the power of it now. Because if I ask you to do any of those things at a graphical environment at the drop of a hat, right? I mean, not with time to prepare applications and to really know what you're doing, but if I just said, connect to this machine, go here, go there, execute this, show me that. If you're in the graphical environment, you got to, unless you've already pre-installed everything, you got to stop, install things. You've got to know all of these ways to configure the applications. You got to know the way they run. You can only do it the way the programmer of that application told you can do it, okay? But in this environment, anything you say, I can probably do it. And I can probably do it within a few seconds, okay? And even if I have to look up the command, I can still do it within a few seconds. All right, so very, very brief introduction, even though it seemed rather long, but it's just, again, it's just scratching the surface. And hopefully this has piqued your curiosity to dig a lot deeper into the command prompt and use this power, and you will be a much more formidable professional.